Hello everyone, I am Mehek and I welcome you to another video of Networks and Communications. In this lecture, I am going to explain to you what subnetting is and how we can calculate the network IDs, host IP addresses and broadcast IPs by just using CIDR. So now let's start with the first question, that is, what is subnetting? Subnetting is the process of dividing a large network into multiple small networks. As we can see that here we have a single network which has its own IP address and it can be subnetted or divided into 4 different subnets. So now let's move forward with the classes of an IP address. An IP address has 5 different classes which are class A, B, C, D and E. But we are only concerned with 3 classes which are class A, B and C. As you can see that each class has its own subnet mask and addressing scheme, and the number of networks, number of hosts and even the public IP address range and private IP address range are different for all the 3 classes. But first of all, we need to know what subnet mask is. A subnet mask is a binary pattern that defines which part of an IP address represents the network portion and which part represents the host portion. In other words, it helps a computer determine whether another computer is on the same network or on a different network. Now as we can see that we can identify classes even from the addressing scheme, like class A is from 1 to 127, class B from 128 to 191 and class C from 192 to 223. So here I have explained the subnet mask for all the 3 classes. In class A, it has 8 network bits and 24 host bits. Therefore, uh, the subnet mask for it will be 255.0.0.0. Now, where did 255 come from in each of the classes? So, as you can see, they are divided into 4 different octets, and one is the value in binary for different values of while raising 2 to different powers. So as you can see that 2 raised to the power 0 to up to 2 raised to the power 7 all hold the value 1. So we are going to add their values and then we get the value 255 here. So the class B subnet mask is 255.255.0.0 and for class C it is 255.255.255.0. We need to remember the subnet mask for all the 3 classes. Now let's try to understand the concept of subnet mask better with an example. In this example, the IP address is 192.168.1.00 and the subnet mask is 255.255.255.0. And from here, what we can analyze is that all the networks which have the first three 192.168.1 will be on the same network. The IP addresses can be classified into 2 systems. One is the classful addressing system using classes ABC and another is classless addressing system or classless interdomain routing, which is known as CIDR. CIDR is a method of representing IP addresses and their associated networks. It was developed to address the problem of the limited number of available IP addresses in the earlier IP addressing system. Next, we need to know what is network ID. Network address is the first address in the network and it is used for identification of the network segment. All the IP addresses using the same network address part are in the same network segment. Another important definition is of broadcast IP. What is it? Broadcast address is the last address in the network and it is used for addressing all the nodes in the network at the same time. So now we are going to learn how to calculate the network ID, the broadcast IP and the host IP addresses with the help of 2 examples. So let's start with this example. In this example, we are given an IP address which is 205.150.65.0/26. So what does 26 signify here? It is the CIDR number. And now we want to calculate the subnet mask for the IP address given. From 205, we can recall that it belongs to class C. So what we are going to do is the subnet mask of class C is 255.255.255.0. We are going to write that down in the binary form, and after converting it, we'll get the first three octets, all the binary digits to be 1, and in the last octet we'll have 8 zeros. So what happens here is in the subnet mask of class C, we have 24 network bits. But what we need are 26 network bits. So how are we going to get 26 network bits? By borrowing 2 bits from the host. So after borrowing 2 bits from the host bits, now we'll have 26 network bits. So instead of 2 zeros, we'll replace them with 2 ones. All that are ones are the network bits, and then we have 6 host bits remaining. So 2 raised to the power 7 plus 2 raised to the power 6 will be 128 plus 64, which is equal to 192. So here we have calculated our subnet mask, which is 255.255.255.192. So that was the subnet mask which we calculated using the CIDR number, and we need to remember the powers of 2 in our mind for that. So how are we going to calculate the network IP? Or it should be network ID. So to do that, we are going to use the logical AND operator. So what happens in logical AND operator is 1 and 1 are 0, 1 and 0 are 0, 1 and 1 is 1, sorry, that's a mistake, and 0 and 0 are 0, and 0 and 1 are also 0. 1 and 1 are 1. Keep that in mind. That was a mistake on my part. So first of all, we write down the address which was given to us in the question, which is 205.150.65.0, and the subnet mask that we just calculated, which is 255.255.255.192. We'll write it down, and then we are going to convert both the address and the subnet mask into their binary forms. So the address in the binary form will be as follows. These are 2 bits are written separately because we borrowed them from the host bits, and now they are part of the network bits. To avoid confusion, I'm writing it like this. So next we have the subnet mask, which we have written in the form of binary. So we'll apply the AND logical operator here. So 1 and 1 will be 1, 1 and 1 1, 0 and 1 0, and so on. After applying it to both the address and subnet mask, we'll get our network ID. So here the network ID comes out to be, after summing up the 2 raised to the powers, converting it into 2 the powers, and then we'll get the network ID after calculating the sum, which is 205.150.65.0/26. We have just calculated the network ID. So how can we calculate the broadcast IP now? For that, I am going to write down 2 formulas that you should keep in your mind. So the first formula is to calculate the number of subnets. The number of subnetworks, which is 2 raised to the power n, and here n stands for the number of network bits. As we can remember that here we calculated the number of network bits in the last octet, which are 2. So the value of n here will be 2. So the number of subnets are 2 raised to the power 2, which is equal to 4. Another formula that you need to remember is that of number of hosts. The number of hosts is 2 raised to the power n minus 2, where n stands for the number of host bits. In the number of subnets, we have number of network bits, and in the number of hosts bits. So the number of host bits are here 6. 8 minus 2, which is going to be 6. So n here is going to be 6, and the number of hosts are 2 raised to the power 6 minus 2, which is equal to 64 minus 2, that equals to 62. Now that we have calculated the number of network bits and number of host bits, let's proceed further with the network ID. Network ID is the first one. So the host address range will start from, as we can see, the number of hosts are 62. So the first one will begin from 205.150.65.1 till 205.150.65.62, and broadcast IP, as discussed earlier, is the last one. So what is it going to be? Yes, it's going to be 205.150.65.63, not 62. Let's move on with the second example now. Now let's move on to the second example, in which the IP address given to us is 205.150.65.0/24. In this, we are supposed to calculate 10 subnets for this IP address. So the number of subnets are already given to us, which are 10, and we need to calculate the number of network bits for this, for the number of subnets, which are 10. So the power of 2 should be greater than 10. So 2 raised to the power 4 is 16, and 16 is greater than 10. So we found the number of network bits. So n is equal to 4. So now we are going to calculate the subnet mask. But for that, first we can see from 205 that this IP address belongs to class C, and for class C the subnet mask is 255.255.255.0. But we are going to calculate the correct subnet mask for this IP address, and n are the number of network bits which we just calculated are 4. So after converting the given subnet mask, which we assumed, into the binary form, the first 3 octets are going to be 1, and in the last octet we have 8 zeros, which are the 8 host bits. So 2 raised to the power 0, 2 raised to the power 1, and so on till 2 raised to the power 7. So we know that number of network bits are 4, so we'll borrow 4 bits from the host bits, and then we'll have 4 network bits and 4 host bits. 2 raised to the power 7 plus 2 raised to the power 6 plus 2 raised to the power 5 and plus 2 raised to the power 4 will be equal to 128 plus 64 plus 32 plus 16, which is equal to, so after calculating, it's 240. So the new subnet mask, or the correct subnet mask for this IP address we just calculated is 255.255.255.240 slash 28, because we have calculated 4 network bits, so 24 plus 4 will be 28. So now we are going to calculate the network ID for this IP address, which was 205.150.65.0/24, and the subnet mask we just calculated, it is 255.255.255.240/28. So what we are going to do is we are going to apply the AND operator again on these two address and the subnet mask. So 205 and 255 are all ones, so it's going to be 205 only. It is a shortcut method of applying the AND operator. It removes the hassle of converting all the address bits and subnet mask into the binary form. Then 150 and 255 again all ones, so into 1 we'll again have 150, because 1 and 0 is 0 and 1 and 1 are 1. So again 65, and we have all ones again, it's going to be dot 65, and 0 and anything with 0 applied AND operator is going to be 0. So now we have the network ID with us, which is 205.150.65.0. So how to calculate the host range? So number of hosts we'll calculate first, which are going to be 2 raised to the power n minus 2, which is n is 4 here, 8 minus 4. So the number of hosts are going to be 2 raised to the power 4 minus 2, which is going to be 16 minus 2. So the number of hosts we have are 14. Here 4 are the network bits and 4 are the host bits. Then the host, so the host range will start from what? 205.150 dot same as network bit 65, and it will start from 1. So number of hosts are 14, so it will go on to up to dot 14. And the broadcast IP, what is it going to be? Yes, you guessed it right, it's 205.150.65.15. So remember to keep this keep these formulas in your mind, 2 raised to the power n and 2 raised to n minus 2, where n are different for both the formulas. So thank you for watching. I hope you understood the concept, and we'll meet in the next lecture.